My overall research goals are focusing on how plants respond to stress and climate change. And as a result of that focus, I've been working generally in three areas: in the Arctic, in the tropics, and I've also been doing work here in the Everglades. One of the areas that I'm very interested in is how climate change will affect the phenology, or the timing of events in the plant's life cycle, because that's one of the things that's most sensitive to warming or changes in rainfall. Most of my research is more related to understanding how the response of vegetation is going to affect climate change itself. So it's quite possible that as the climate changes, the climate change could actually be increased or dampened depending on the response of vegetation. A good example of that is that a paper just came out that's saying that methane, which is one of the very strong greenhouse gases, is increasing as a result of climate warming. So basically climate warming is causing more climate warming. So that's the kind of thing that we're looking at in terms of the vegetation. Working mostly in northern Alaska, and my work focuses on trying to understand what's the balance of greenhouse gases with the Arctic tundra. And the issue with tundra is that there's a very large amount of carbon stored in the soil. If the soil dries out or if the soil becomes warm, that carbon could decompose, oxidize, end up in the atmosphere as CO2 or as methane, and that would cause more warming. So that's the big focus on the Arctic. In Costa Rica, I'm working kind of on the other end of the equation. If you think about the balance of carbon dioxide in the atmosphere, plants are taking out carbon dioxide in photosynthesis, and plants are respiring, they're releasing carbon dioxide as they basically do what we're doing, breathing in a sense. They use oxygen and release carbon dioxide when they're not able to photosynthesize. And the focus on the tropics is that the tropical rainforests are really the strongest areas globally in terms of pulling out carbon dioxide from the atmosphere. And what we're seeing is that that's starting to change, that they're not doing as well as the climate warms. So my work in Costa Rica is focusing on what's the carbon balance, particularly how does photosynthesis and respiration play out with the climate warming. And what's happening in the tropics right now is the nighttime temperatures are increasing. The focus on the Everglades for me is it's really two things. One is that it's here and it's locals. The other reason is that wetlands are a very strong player in greenhouse gases. They're a source of methane going to the atmosphere, because methane is generated when you have soils that don't have oxygen in them, or very little oxygen, and so there's microbes that release methane rather than releasing carbon dioxide. And the other thing is, because the soils are very wet, they have the potential to store a lot of carbon because there is no oxygen in the soil, and the microbes, although they can break down some of that, releasing as methane, they can't break down very much. So wetlands have this potential to store a great deal of carbon in them. And the issue about the Everglades is that the water regime that they currently have is under management by a computer model that is primarily operated by the South Florida Water Management District, and how that management affects the carbon balance of the Everglades is really interesting, and it turns out to be pretty sensitive to what the water management people are doing. And so we're trying to figure out how this system responds to changes in water.